So for Unit 6, Day 14 practice, we're building off of what we were working on with the Desmos lesson yesterday. The biggest idea is when you're working with your triangles to label your sides for the right triangles. What's your hypotenuse? What's opposite from your reference angle where you're standing at? And what's adjacent next to you but not the hypotenuse? So if you look at your slide 2 here on Class Kick, remember once you label, you're going to figure out, are you going to use the opposite to hypotenuse? Use the ratio for opposite of hypotenuse or adjacent over hypotenuse. And if you click on this link here, you're going to have both of those sliders. So make sure you're watching which one you're selecting. The first slider should be the opposite over hypotenuse. The second slider should be the adjacent over hypotenuse. Make sure you're showing all of your evidence, the proportions that you're using, the steps you're doing to undo the proportion to solve for the variable, whether it's the side or the angle. And then it asks you to round to the nearest hundredth for the side lengths and the nearest degree for the angle. We gave you a couple of examples about your rounding below. So if we look at number 1, here we have our right triangle. And again, step 1 is to label your sides. So remember, we stand at the acute angle, which would be the 25 degrees, and we label the triangle accordingly. Always across from the right angle points to the hypotenuse. Again, if you laid your pencil down at your reference angle, across from it would be the opposite side, and that leaves the adjacent side next to you, but not the hypotenuse. So if I'm looking to see what I'm working with, X is the adjacent side, hypotenuse is 70. We're going to use the adjacent over hypotenuse for this triangle. So when I think about what that looks like, the adjacent side is X, the hypotenuse is 70. So I'm working with X over 70 equals. And to find the other part of my proportion, I know the angle measurement here of 25 degrees. So I'm going to go to my slider for adjacent over hypotenuse and adjust it to 25 degrees so I can find that decimal side ratio to complete my proportion. So if I'm going to do that, here is the decimal side ratio I need, 0.90631. So I'm going to substitute that into my proportion, and then I'm going to solve for X. So here again, we're going to do cross products. So I'm going to do X times 1. I'm going to do 70 times 0.90631. Notice in doing this, X is already isolated, so I just need to do this calculation to solve for X. And I get this. So if they're asking you to solve to the nearest hundredth, we look at that third decimal place. And it's going to tell us, are we going to raise the second one, the hundredth, or keep it as is? Since it's a 1, we're going to keep it at 63.44 units. So let's look at another triangle. This is number 10 on your handout. And so if we look at our triangle here, again, you want to find the reference angle. So our reference angle is 40 degrees. From that angle, we're going to label our pieces. So we know our hypotenuse is 6.14. Across from us is the adjacent side. Across from us is the opposite side, X, and then our adjacent is next to, not the hypotenuse. So for our problem here, we've got the opposite and the hypotenuse. That's what we're going to use to solve for our missing length. So if I think about this, getting my proportion started, opposite over hypotenuse, X over 6.14 equals some other ratio over 1. So I have the angle measurement here, 40 degrees. I'm going to set my slider to that angle and see that I need 0.64279 to complete my proportion. So once I have that, again, we're going to do our cross products to help us solve. X times 1, 6.14 times 0.64279, and that will give our value for X. So again, with rounding, we look at the third decimal place. It's going to tell us if we're going to round the second one up or keep it as is. Since it's above 5, I have to round this up. So we're going to see our side length is 3.95 units in length.
Mommy, now my bones hurt.
All right, if we get to number 13, again, we're trying to solve for X. So X this time is an angle, and that's our reference angle where we're standing at. So we want to label our picture according to where we're standing. So we know that the hypotenuse is 12, the opposite side is 4, and our adjacent side is here. So if we look, we're still working with the opposite and the hypotenuse. And so we're going to start working on setting up our proportion. So opposite over hypotenuse would be 4 over 12. At this point, we'd say, typically, what angle measurement do I have here so I can set my slide or do my proportion? However, that is the unknown. So what do we know? Well, we have this ratio here of 4/12. I can find its decimal equivalent and use that to find the angle. So when we take 4 and divide it by 12, we get 0.3 repeating. So I want to adjust my opposite over hypotenuse slider to try to meet that ratio without exceeding it. So I'm going to go to the opposite over hypotenuse sliders, and I'm going to look to see what my options are. So I can get to 0.32557 or 0.34202. Again, I don't want to exceed the ratio. I want to get as close to it as possible without going over. So of the two angle measurements, 19 degrees and 20 degrees, what's the better fit? We would want to go with the 19 degrees because that's just below our ratio of 0.3 repeating. So X is approximately 19 degrees for the angle measurement. So that's what we're practicing today. You have the remaining problems on your day 14 handout that coincide with your day 14 class kick for you to practice your ratios, whether you're working with opposite over hypotenuse or adjacent over hypotenuse. The key is to label the triangles, adjust the sliders to find your missing pieces. Class kick is programmed for you to enter your results for the side lengths rounded to the nearest hundredth and angle measurements to the nearest degree.